So here we are given the rational function ax plus b over cx plus d. So we need to find its derivative with respect to x using the quotient rule. So to the quotient rule, we start with the denominator. So we consider the denominator cx plus d. We square it and write it in the denominator. Then in the numerator, we start with the denominator cx plus d and then multiply it to the derivative of the numerator, which is ax plus b, minus ax plus b times the derivative of the denominator, which is cx plus d. So now, finding the derivative, we have cx plus d multiplied to the derivative of ax. Now a here is a constant, so that can be pulled out of the derivative, leaving us with only x inside, plus the derivative of b minus ax plus b times the derivative of cx, so c being a constant, we pulled it out of the derivative of x with respect to x, plus the derivative of d, whole divided by cx plus d whole squared. So we have cx plus d multiplied to a times the derivative of x is 1, plus derivative of b being a constant is going to be 0, minus ax plus b times the c times the derivative of x, which is 1, plus the derivative of d is going to be 0, divided by cx plus d whole squared, which is equals to a times cx plus d minus c times ax plus b, divided by cx plus d whole squared. Now we can solve for the numerator, and that was going to give us acx plus ad minus cax minus cb, divided by cx plus d whole squared. So the acx and negative cax gets cancelled, so the final derivative will be equals to ad minus cb divided by cx plus d whole squared. So this is the derivative with respect to x. So let's move on to the next question. So here we have the function px squared plus qx plus r over ax plus b. So we need to find its derivative with respect to x. So using the quotient rule, we get ax plus b whole squared in the denominator, and in the numerator we have ax plus b times the derivative of px squared plus qx plus r minus px squared plus qx plus r times the derivative of the denominator, which is ax plus b. So this gives us ax plus b multiplied to the derivative of px squared, so p being a constant, we can pull it out of the derivative, plus q times the derivative of x plus the derivative of r minus px squared plus qx plus r times derivative of ax, which will be a times the derivative of x plus the derivative of b, whole divided by ax plus b squared. So we get ax plus b times p, so derivative of x squared will be 2x plus q times derivative of x with respect to x is 1 plus derivative of r with respect to x is 0 minus px squared plus qx plus r times a times 1, which is the derivative of x with respect to x, plus derivative of b with respect to x is going to be 0, whole divided by ax plus b whole squared. Now simplifying the numerator, we have ax plus b multiplied to 2px plus q minus a times px squared plus qx plus r, all divided by ax plus b whole squared. Now we multiply the two terms, ax plus b and 2px plus q, so we have ax multiplied to 2px plus q plus b times 2px plus q minus a times px squared will be apx squared plus aqx plus ar, whole divided by ax plus b whole squared. So we get 2 times ap x squared plus aqx plus 2bp x plus bq minus ap x squared minus aq x minus ar, whole divided by ax plus b whole squared. Now I can combine apx squared, 2ap squared and negative apa squared. aqx and aqx will get cancelled, so we get apx squared plus 2bpx plus bq minus ar over ax plus b whole squared. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function 1 plus natural log of x divided by 1 minus natural log of x. So we need to determine the derivative of this given function with respect to x. So we'll get 1 minus natural log of x whole squared in the denominator. Then we begin with the denominator. We have 1 minus natural log of x multiplied to the derivative of the numerator, which is 1 plus log of x, minus the numerator 1 plus log of x times the derivative of the denominator, which is 1 minus log of x, which will give us 1 minus log of x multiplied to the derivative of 1 plus the derivative of the natural log minus 1 plus natural log of x times derivative of 1 minus derivative of natural log of x whole divided by 1 minus natural log of x whole square. So that is equals to 1 minus natural log of x multiplied to, so the derivative of 1 with respect to x is 0, and the derivative of the natural log with respect to x is 1 over x minus 1 plus natural log of x times 0, derivative of 1 is 0, so we have negative the derivative of log of x, which is 1 over x divided by 1 minus natural log of x whole squared. Now the negative and the negative will get multiplied, and this will give us positive. And what we can do, we can take 1 over x as the common factor, so that will leave us with 1 minus log of x plus 1 plus log of x in the numerator, and in the denominator we have the common factor x times 1 minus natural log of x whole squared. So the log of x gets cancelled, and finally we get 2 over x times 1 minus natural log of x whole squared. So this is the derivative of the given function with respect to x. Now let us move on to the next question. So here we have the function 1 plus 3 raised to the power of x divided by 1 minus 3 raised to the power of x. So we find its derivative using the quotient rule. So we'll have 1 minus 3 raised to the power of x whole squared in the denominator. And in the numerator, we begin with the denominator, so that is the function in the denominator, which is 1 minus 3 raised to the power of x multiplied to the derivative of the function in the numerator, which is 1 plus 3 raised to the power of x minus the function in the numerator, which is 1 plus 3 raised to the power of x times the derivative of 1 minus 3 raised to the power of x, which gives us 1 minus 3 raised to the power of x times derivative of 1 with respect to x plus derivative of 3 raised to the power of x with respect to x minus 1 plus 3 raised to the power of x. So we have derivative of x with respect to 1 minus derivative of 3 raised to the power of x raised with respect to x divided by 1 minus 3 raised to the power of x whole squared, which will be equals to 1 minus 3 raised to the power of x. So derivative of 1 with respect to x is 0. Then derivative of 3 raised to the power of x with respect to x is 3 raised to the power of x times natural log of x minus 1 plus 3 raised to the power of x multiplied to we have 0 minus 3 raised to the power of x times natural log of x whole divided by 1 minus 3 raised to the power of x whole square. Now the second term in the numerator will become positive because negative times negative is positive. Now we can take 3 raised to the power of x times natural log of x as the common factor from both the two terms in the numerator. That leaves us with 1 minus 3 raised to the power of x plus 1 plus 3 raised to the power of x whole divided by 1 minus 3 raised to the power of x whole squared. So 3 raised to the power of x gets cancelled, and that gives us 2 times 3 raised to the power of x times log of x divided by 1 minus 3 raised to the power of x whole square. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the rational function x squared minus x plus 1 divided by x squared plus x plus 1. So let us find its derivative with respect to x using the quotient rule. So we'll start with the function in the denominator, x squared plus x plus 1, square it and write it in the denominator. Then we again begin with the same function, x squared plus x plus 1 times the derivative of the function in the numerator, which is x squared minus x plus 1 minus. So there's another way to remember this formula. So what we can do, all we have to remember that there's a negative when we are doing the quotient rule. Now that we have already formed the derivative of the function in the numerator, so what we do this time, we have to find the derivative of the function in the denominator. So we consider the numerator and then multiply it to the derivative of the denominator, which is x squared plus x plus 1. So that will give us x squared plus x plus 1 multiplied to the derivative of x squared minus the derivative of x plus the derivative of 1 minus x squared minus x plus 1 multiplied to the derivative of x squared plus the derivative of x plus the derivative of 1 whole divided by x squared plus x plus 1 whole squared. So we have x squared plus x plus 1. Now the derivative of the x squared function will be twice x minus derivative of x will be 1, and derivative of 1 being a constant will be 0, minus x squared minus x plus 1 multiplied to derivative of x squared plus the derivative of x whole divided by x squared plus x plus 1 whole squared, which will be equals to, now we're going to multiply 2x minus 1, 2x squared plus x plus 1. So we'll get 2x times x squared will give us 2x cubed, 2x plus x is going to give us 2x squared, and 2x multiplied to 1 will be 2x. Then we have negative 1 multiplied to negative x squared, x and 1, minus we have x squared multiplied to 2x, so that will be 2x cubed, plus x squared multiplied to 1 gives us x squared, and minus x times 2x will give us negative 2x squared, minus of x plus 1 multiplied to plus 1 will be negative x plus 1 multiplied to 2x plus 1 whole divided by x squared plus x plus 1 whole square. Now we remove the parentheses, so when we do that, all the signs will flip, the positive will become negative and vice versa. So let's change it. So this was positive, so this will become negative, then positive x square will become negative x square, negative 2x square will become positive 2x square, negative x will become positive x, and negative positive 2x will become negative 2x. So now we can cancel out all the opposite terms. So 2x cubed gets cancelled, 2x will also get cancelled, x squared, no, negative x and positive x will get cancelled. So we have now 2x squared minus x squared minus x squared, so that will also get cancelled. So that leaves us with only negative 2 in the oh, we have a 2x squared here. So we have a positive 2x squared minus 1 divided by x squared. Oh, that will be 2. Negative 1 and negative 1 will give us negative 2 divided by x squared plus x plus 1 whole square. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function. We need to find its derivative with respect to x. So we get square root of a minus square root of x whole squared. We have square root of a plus square root of x multiplied to the derivative of the numerator. So let me do it straight away. So we have derivative of square root of a plus the derivative of square root of x minus the numerator, so square root of a plus square root of x multiplied to the derivative of the denominator, which is square derivative of square root of a minus the derivative of square root of x. So we get square root of a plus square root of x multiplied to, so the derivative of square root of a will be 0 because a is a constant, so square root of a will be another constant. So we have simply the derivative of square root of x. So the derivative of square root of x will be, so we can rewrite it as square root of x can be rewritten as x raised to the power of half. So similarly let's change it here as well. So we have x raised to the power of half. So this will give us, so using the power rule, so we have half times x raised to the power of half minus 1, which will be negative half, minus the square root of a plus square root of x times differentiation of square root of a will be 0, so we have negative half times x raised to the power of negative half, all divided by square root of a minus square root of x whole square. Now the negative and negative, the second term, the negative times negative will become positive, and what we can do, we can take half times x raised to the power of negative half as the common factor in the numerator. So that will leave us with square root of x plus square root of a plus square root of x plus so made a mistake here. So this is the denominator, which is negative. So here we have square root of a minus square root of x plus square root of a plus square root of x divided by square root of a minus square root of x whole squared. So negative square root of x and positive square root of x gets cancelled. So that leaves us with half. So we can bring the x to the denominator, so times 2 times the square root of a divided by square root of a minus square root of x whole squared. So the 2 and 2 gets cancelled, and that leaves us with square root of a divided by square root of x, which comes to the denominator, multiplied to square root of a minus square root of x whole squared. So this is going to be the derivative of the given function with respect to x. Let's move on to the next question. So we have the rational function ax squared plus bx plus c divided by px squared plus qx plus r. So let's find its derivative with respect to x. So we will have px squared plus qx plus r whole squared in the denominator. Then we begin with the same denominator in the numerator. So we have px squared plus qx plus r times the derivative of the numerator. So the derivative of the numerator will be 2ax plus b. So a being a constant, so a will be multiplied to the derivative of x squared, which is 2x, so that gives us 2ax, plus b times the derivative of x, which is 1, so we'll have b, and derivative of c is 0. So minus ax squared plus bx plus c multiplied to the derivative of the denominator, so that will be 2px plus q. So now we can multiply the numerator, so we have 2ax multiplied to px squared, so that will be 2apx cubed plus 2aqx squared plus 2arx plus bpx squared plus bqx plus br minus 2pax cubed plus aqx squared plus 2bpx squared plus bqx plus 2bcx plus qc whole divided by px squared plus qx plus r whole squared. Now we remove the parentheses. So we have minus aqx squared minus 2bpx, so everything will become negative. So let's remove all the positive signs and replace it with the negative sign. So 2apx cubed will get cancelled. aq, we have 2aqx squared. So yeah, so this term and this term will combine to give us aqx squared. Then positive bqx, negative bqx gets cancelled. We have 2arx. There's no 2rx term, so let's write it down. 2arx. So this is complete, and this is complete. So bpx squared and negative 2bpx squared will give us negative bpx squared. And we have br plus br negative 2bcx minus qc divided by px squared plus qx plus r whole squared. So rearranging the terms, we have aq minus bp x squared plus 2 times ar minus pc times x plus br minus qc whole divided by px squared plus qx plus r whole squared. So this is the derivative of the given function with respect to x.